Okay guys, welcome along to a 9 a.m. session on the last day of TechEd. I hope you've been enjoying TechEd so far. Who was at the party last night? Oh, a decent smattering of you. Okay, I will keep my voice down, sorry. Okay, well my name's Mark Young. I work at Datacom here in Auckland. And this morning I'd like to go through performance. Performance, especially Windows Store applications. And I want to look at what do you do when things aren't going flash. So I want to guide you through some of the dark alleyways, through some of the crazy pieces, about how to make your apps into the fast, fluid, and efficient masterpieces you'd like to be. Now, one of the cornerstones of Windows app development is fast and fluid. It's something that was brought out at the beginning. And for the most part, we're able to do that out of the box as part of our default Windows Store applications without doing anything. So that's the best scenario. We don't want to have to even worry about performance. But what do you do when the users start complaining? What do you do when your boss throws a sad? What do you do when your battery life is dying faster than a Game of Thrones character? So today what I'm wanting to do is I really want to give you an overview. I want to give you an idea of the tools that you can use when you need to do performance tuning. So that when you come to do it, you're not just going to have to throw your hands up in the air and scream. I'll go forwards rather than backwards. So today what I want to do is I want to look particularly around Windows Store applications, but a lot of this will apply to other pieces as well. I want to look at some of the common performance scenarios. So these are the cases that we have to worry about in our applications. Making them fast, which is, we'll find out what that is. Making them fluid, making them efficient. I particularly want to guide you through the tooling that's available, because Studio 2013 and Windows 8.1 has got a lot better tooling than what we had before. And then I want to go through some techniques for performance optimization. So once you've identified what's wrong, how do you fix it? So this will be at least a 300 level session today. I'm not going to be coding heaps, but some of the tools do take a little bit to get your head wrapped around. Now please fire away with questions at any stage. If you make this question driven, there's not that many of us here. It'll certainly make my life a lot easier. So throw your hand up, questions at any stage. If you want me to show you something different in a tool, then let's go with it. So that's sort of where we're going with our performance. So I originally wanted to entitle this talk, Performance Tuning, It's Not a Black Art. But then I tried doing some, and I realised that wasn't true, so I had to scrap that title. Then I was like, well, it's easier than you think. But then I tried doing some more. So the final one I've come up with is it's not as scary as it used to be. So what I want to show you today is that performance tuning, it might still be a bit of a black art. This still takes a whole lot of skill. It can still result in head bashing and keyboard mashing and things just not working. But it's certainly a lot easier than what it used to be. Or at least there's much better tooling available than what there had been at other times. So first up, just to kick in, why does performance matter? You know, why should we care about performance with our apps? It's good enough on my machine, you know, it'll run. Do you want to get up here? Bingo. Okay, so here's a couple of stats. From the App Store, and this one here is based on all the app stores across iOS. It was a survey done by a crowd, and it is a crowd who's trying to solve performance issues. So they've got a bull to chain. But anyway, let's go. So some of the top 4 reasons why users uninstall an app. 75% of people said they uninstall apps because they freeze, or because they crash, or because they've got a slow response, or because they chew up the battery. So if your app does all these things, or any of these things, users are much more likely to uninstall it. Conversely, some of the top rated applications, the ones that are getting your 3s, your 3.5s out of 4, they've all got a really short startup time. Now I'm not saying that there's a causation here, but there certainly is a correlation between applications that users love and ones that perform well. And as we've said, if applications perform well, users are much more likely to use it. They're more likely to spend money. They might buy your application. They're going to spend more time on it. Or maybe if it's a line of business application, you're not going to get so many calls to the support desk saying this thing's slow or grumbles against your application, and they might even use it. It's often said that performance is a feature. And this is something I think that's actually got two edges. So if you treat performance as another feature in your application that's similar to screen X or screen Y, well, you can do two things. One, you know about it up front. But two, you can decide where you want to prioritize it. So you can decide that performance doesn't matter more than screen A, and you can put it down the list. Or maybe performance is number one, on your system, and instead of task 24, you're going to make it task 1. So if performance is measured as a feature inside your application, and you've got some metrics and some requirements up front, then you're able to put it on the task board. And as we've said, just skipping through this, first impressions really do matter. When I first open up an application, that's the memory I'm going to take with the application. If it takes forever to load, then I'm going to think it's a slow piece of rubbish, even if it's got all the features in the world. Secondly, battery life matters. The first thing I want to do on my phone or my device is see which applications are using up the most amount of battery, and I'm going to uninstall them. So we don't want that to be our application. Similarly, the operating system will look at which one's using up the most amount of memory, and they're going to kill that. We don't want that to be our app either. And particularly nowadays, we want to cater for a range of devices. Windows Store apps normally perform fine on dev machines. I've got an i7 here, and I almost never see any issue. But if users, and we're going to be looking today at one of these ARM devices, Atom devices, but when users are working on these slow devices, then they're really going to notice it. Or maybe our IT department wants to be able to save money, and they want to just be able to push out Atom devices to everyone because they're $400 a pop, rather than $1,000. If our app runs fast on that, then hey, we can save a lot of money. So the parts of performance that I want to look at today, there's really 3 pieces of performance. And you've heard these probably bandied about. Fast, fluid, and efficient. So fast is all about how long do things take to happen. How long does my application take to start up or to resume after it's been suspended? How long does it take to navigate between pages? When I click on a button, do I have to wait for 5 seconds, or is it going to go straight there? Fluid is all about when I'm scrolling around the screen, does the content keep up with my finger? As I move my finger across, does the scroll view happen, or do I see glitches? Do I see little blocks coming up and things that shouldn't be there? It's fluid. And efficient is all about memory usage and battery. Does my app chew up the battery? Does it chew up the memory? So let's just take a look at an app that I've built, and this is a demo app that I'm going to be showing you today and showing lots of pieces as we dig into it. So I've got here my little 8-inch device, and this is running an Atom processor, so it's running pretty slow, which is nice for our demos because it's going to show a lot of things. I'm going to click this app and open her up, and if it opens, and she's a bit slow. So that's performance number 1. It took a while to open up. What I've got here is a hub view showing a list of a whole bunch of speakers who are here at TechEd. Anyone in my Windows 8 talk probably saw the same screen. And what I can do here, so that screen's not too bad. Let me click through onto the next one. Hey, that one loaded pretty quick too. And I can scroll away, and the screen's pretty good. But let's go back to maybe some of our other screens. Here's my second one. Oops. Hello. So that's not a very flash-ish thing. That's a fluid issue. Or maybe we've got an issue like this, which didn't demonstrate it at all. But that's okay. We'll go back to our other version. Or this one here, that as I scroll about, nothing's keeping up with me. I'm starting to get jerks going around. Oh, we've already seen that one. No worries. So I've got 2 or 3 issues there inside my application. Ones that are fast, things took a long time to start up. Or fluid, things that didn't look too flash as we were going around. So what I want to dig into over the next part is the tools that we've got in our toolkit to be able to figure out what's going on with this application and what's going on with other ones. Things I want to show you. I want to show you remote debugging. Remote debugging is really, really powerful because it means that I can develop on my laptop and I can test it on something that's slow. The Performance Hub. This is new inside Visual Studio 2013, so I'm going to guide you through this. And this applies not just to Windows Store development, this is also available for desktop and for internet development as well. CPU sampling and memory profiling are tools that we're probably aware of. They're tools that have been around for a while, so I'm not going to go into them. But the energy consumption is something that's new as well. So I'm going to look at the energy consumption tool. And then lastly, we're going to dig into some of these more advanced tools, the Windows Performance Toolkit, which has got two parts, the recorder and the analyzer, and take a look at how we can use that inside our application. Now, just out of interest, how many of you guys here are devs? Cool. How many of you have had to do some sort of performance tuning in some sort of application before? How many found it a really, really quick and easy job? Cool. Sorry, just checking we're actually on the same page here, because I didn't put my hand up for that one either. So I want to look at fast first. And just before I dig into the tools, I'm just going to talk a little bit about fast, and then I'm going to show you these tools in action. So fast, remember, is all about this navigation between pages and opening pieces up. So what happens when we're doing something here inside a Windows Store application? We've got 3 threads at play. So there's 3 different processes that are at play here inside the system. It's something I really want you to understand. We've got a UI thread. This is what we're used to in our desktop applications. This is our single thread that everything happens on inside our app. Whenever we make application code or whenever a callback comes into our application, that's what's happening. And the UI thread is responsible for loading up our application, passing all the XAML, laying all the controls out on the screen, building up that element tree that we have, applying all the templates, doing the data binding, processing our input like our touch devices, running all that application code that's not running on the thread pool, and then finally taking all those elements and rendering them into pixels. So the app thread, the UI thread, is responsible for just about everything inside our app. But Windows Store introduces a couple of extra pieces, which is really nice and enables us to make responsive apps that we can't do in something like WPF very easily. We've got a second render thread. So the UI thread has created rendered elements into a bitmap for every element on your screen, but it's kept them all separate. The render thread is responsible for laying out those elements on the screen. So if we've got a block that's moving on the screen, the UI thread doesn't have to do anything because the pixels of that block are not changing. So the render thread is able to move that around because its job is all about that layout. What it can also do is apply animations. So any time it doesn't need data from the UI thread, let's say we've got a spinner, and the spinner is able to control, and all it is doing a transform. It's just spinning around and around. The pixels of that element are not changing. The render thread is able to do that. So what this means is that we can see animations happening as long as we don't have to update any values while our UI thread is completely blocked. And then finally, we've got DWM, which is a desktop window manager. This is really your GPU, and its job is to combine together those frames that the render thread has figured out where they live. So the render thread takes the bitmaps, figures out where they should be on the screen, including any transforms, and then the window manager combines those layers together, so applying any opacity, any alpha, or anything to get it up onto the screen. Does that make sense? Any questions about that? Cool. So, when we have a slow startup is always just about the UI thread. Because the render thread and the others are only involved when you're actually showing it on the screen, we know it has to be something there on the UI thread. And I listed there a whole bunch of responsibilities of the UI thread, and there's some causes next to it. So if parsing's taking too long, well then you've probably got too many XAML files. If layout's taking too long, then you've got too many elements to lay out. If applying your templates is taking too long, your templates are too complicated. If your data binding's taking too long, then you've got too much reflection or something crazy going on. So it's pretty simple in this, that if something's taking too long, you've got too much of it. But the questions really are, how do you know which one of these pieces it is? And how do you cut down on the amount of work that those pieces are doing? So we're going to see that in a minute. What I want to do now, and is to show you some of these tools. So I'm going to jump here into Visual Studio. 1, 3. And I've got my application open. Let's just close down some of these code. Yep, go for it. I'm not showing yet. How about I switch that across to the correct screen? Thank you very much. Inside Visual Studio, now, there's this new Performance and Diagnostics hub under the Analyze menu. You guys will see that? And that brings up this new screen, which has got some of the existing tools, but also some new tools under it. When we're in a XAML app, we've now got this new piece called the XAML UI responsiveness. If I just zoom in on this so you can actually see it. So here's our available tools. We've got CPU sampling. That's something we were aware of before. But we've now got the energy consumption and the UI responsiveness. Now, the Performance Hub here is your high-level first hit. Okay, this is your easy tool that's really easy to use. It doesn't take much time, but it doesn't also give you as much data as some of the other tools. Just before I do that, I'm going to show you remote debugging. Who's used remote debugging before? Remote running? Not too many of you. A few though? Okay, it's easy to set up. What I'll do is I'm just going to flick back here to my laptop. And I've installed on this device the remote tools inside Visual Studio. And with that comes this one here called the Remote Debugger. All I need to do is open that up, and that's now going to sit on the network waiting for someone to hit into it. Inside my application, when I'm going to run, I can choose from our existing simulator or local machine or a remote machine. And when I select remote machine, the first time at least, that's going to prompt me for what machines are on the network. I can clear this. Let me just debug. We'll turn off. Nope. Okay, I'll put this back onto local. Let's just see if this does it. No, we'll go into remote. Okay, the first time it does it, something like this shows up. And this should show me all the machines that are on my network that have got remote debugging enabled. So I'm just going to select this machine here, the Acer. And just to prove this, and I'll see how quick my switching is, I'm going to hit F5 here, switch back to this machine, and in 3, 2, 1, 2, 3, 2, 1, I should see the application opening up. And normally it's not actually quite that slow. But this means that it's almost no slower than running it on my local, but I'm able to see all the performance metrics from that machine. So if we just flick back to the laptop, I'm just going to close that down. And let's start off this UI responsiveness. Now again, under here, when I run this tool, I can choose to either run it on my local or run it on the remote machine. Go for it. You can do it via USB, but no, actually, let's go back. It needs a network connection. So if you can set up your USB to count as a network connection, then that'll work fine. I've got my own private Wi-Fi here because I didn't want to rely on the system. And over a good Wi-Fi connection, it's fast. I've personally never used it over a straight USB. Nigel, is that possible?
I've never tried.
Okay. Make sure you've got a fast network connection. And my easiest way is I use a dedicated hub and I just connect them both to that same Wi-Fi network, and then it's fast. But it's really good because it means you get the performance metrics on that device, and it's actually just as fast as running on my local when I'm not having to switch, so I can keep developing and just go run, run, run. It almost is a faster workflow. So when I select this guy here, this is actually where the performance tools will run. So I'm going to stick it with it on the local machine, and I'm just going to kick this off and hit start. And that's going to launch my other one. So we'll just flick across to that to see that launching. And so this is exactly the same as remote debugging. It should launch if I hit the wrong thing. I've got a black screen here. That's not a very good start.
Is it just slow because of the...
No, it's slow because I've run out of power on my machine. That's a good start. I charged it fully last night. Come on, this is crazy. My machine has just turned off. No worries. Hey, Nigel, would you be able to come up here and plug this in for me, please? Just while I go on and show this stuff. But what I'm going to do is I'm going to kill that inside my bag. It's the one in the front somewhere. Just pull everything out with that charger there. Yep. Nope. Yes, that one there, but you'll need there's a plug up here. Go for it. I do have an adapter. Okay. Let me just do this on my local machine so you can see it happening while I'm talking away. So I'm going to swap back to my local machine. There's an adapter up here, mate. And I'm going to click Start. So when I click Start, this is now going to load up the same app, but on my local machine. Okay, I'm going to click Yes to say I accept it's using pieces, it's recording, and then it's going to run. So while this takes a little second, okay, that's the startup time, and I'm just going to click around a couple of pieces just to show this happening. Yep, so there's a little bit of lag there. It's not too bad, but a little bit of lag. So I'll close this down and stop the collection. So this tool's nice because it's reasonably lightweight. It doesn't actually take that long. And by not long, we'll see what that actually means. Okay. This thing here looks to be completely dead. I have just bricked my Acer device. That's going to be interesting for the rest of the talk. We'll get there. So let's look at these tools anyway. I've got some of these pre-canned and ready to go. This device is just bricked. We can see here in this tool, it gives us a nice layered breakdown of what's happening inside our application, grouped by high level what it's doing. So if we look across here at the key, blue means passing, orange here is layout, green is our application code, and grey is our other XAML. So we can see at the beginning, we've got a heap of application code, although we had a gap here for a little bit. So I can see here that my 5 seconds, which is the time up to this performance marker that it's actually finished navigating, is an application code issue. So now that we know it's an application code issue, we can run that through our normal application profiling tools. No, I'm going to have to give up on this device. It's completely gone. Okay, so that there is an issue, application code. Just to dig into this a little bit more, I've got some traces that I've already got. If our issue is in layout, we might see something that looks a little bit like this, with a heap of these orange bars. And if it's an issue with layout, what we can do down the bottom is have an idea of the hot elements. So this gives us a breakdown by control on the screen. So let's dig into this, dig that one open. We've got grid view items. Inside the grid view item, we've got a presenter, and then we've got our text blocks inside that. We're able to dig into this to see if we've got a data template that's expensive or anything like that. It gives us a really good, quick view of what's going on. Any questions about that? Go for it.
Sorry, did you say this was for 2012?
This is only part of 2013. So you want 2013 for these tools because this makes your life so much quicker. You know, that was just run the start and go for it.
The one you highlighted there is 181 milliseconds.
Yes?
Looks like the breakdown of that doesn't come in here 181 milliseconds.
Okay, well this one here takes that amount, and these ones here are taking a lot. So that means that it's this element here, something in that grid view presenter that's actually got inclusive time. Okay? And then I'll show you actually, we should go through it, how to dig further into that later.
What version of Visual Studio?
This is 2013, the release candidate one that came out 2 days ago.
Like professional.
This is available in all versions of Professional and up, I believe. I'm not sure about Premium. It's definitely in Professional. You don't need Ultimate for this. I can't comment on Premium. Sorry. So that's our initial look at that tool. Really, really easy. Now the second tool that we've got, and actually, the other one I should show you. This one's quite nice. So we can select an area, and it shows here which XAML files are local. So if we've got a parsing issue, if we've got heaps and heaps of blue in this file, which I don't have because I've only got 2 files, I'm able to look and see which XAML files are being loaded as well inside which timeline. So that's just another piece if you've got an issue with your parsing, or you've got too many XAML files, or maybe it's actually really useful because you actually want to see what XAML files are being loaded. So it's actually quite good just for your application. Down below, and we'll see further into this later, we've got a couple of lines just checking how things are performing. Your green line there is your rendering thread. That should be constant at our 60 frames per second. 60 frames per second is the magic number in the framework that we're going to dive into in a second. So we want that number to be constant. And the one underneath it is our application code. So this is how many frames we're able to get through in our UI code every second. So that there is the performance hub, and we'll look at the energy part of it later. The second tool we've got is called the Windows Performance Toolkit. Now this is a separate download and a separate install, but it comes as part of it. And this was part of Windows 8, but the tooling under 8.1 gives you a lot more scenarios that you're able to pick up to. In the Performance Recorder and the Performance Toolkit, so we use the recorder to record a trace, and then the toolkit the analyzer is what we use to analyze the trace. The first one I showed you before can be run on a remote machine. This one can't, but it can be run from the command line, and then your traces can be exported. So what we do first is we open this up, and we're initially given a set of scenarios and options that we can pick from. So these are what metrics that we're going to record. This stuff hooks into event tracing for Windows, which is a new logging framework that's part of Windows. How many of you guys have seen ETW or used event tracing before? No? Okay. How many have heard of event tracing for Windows before? Okay, I think that's a bit like me. It's just one of these top products that are coming out that we all know we should use, or that everyone's saying that we should use, but it's still jolly hard to use. So 8.1, and we're going to see a bit later, makes it a lot easier. But this hooks into metrics that are available all across your system, and it's amazing the amount of stuff that Windows pushes out. The good thing with this stuff is that it doesn't record unless someone's listening. Okay, so what we're going to do here is set up this recorder, and this listens to a lot of these metrics. So the options I'm going to pick, we've got a first level triage, and we can go down to a scenario analysis, and I'm going to pick XAML. Now this is actually really heavyweight, but that's okay. So I'm going to click Start, and then launch our application. This is recording across all of Windows, so you can use this for recording our built-in Windows applications or your own. You don't have to be running through Visual Studio to use this. I'm just going to close that down and go back to our recorder and hit Save. Now this is going to pull out a big log, and it's going to take a while to record. So here's one I prepared earlier, he hopes. Just going to start from, actually let me start from scratch. So I'm going to load up now the Windows Performance Analyzer while that log's going on. And so the Performance Analyzer is what I use to read through these trace files. And I'm going to open up the most recent one that I did, which we'll call it that one, or just any one. Oh, that's loading up. Doesn't take as long as the recording, he says confidently. I should have warned you, today could have a few delays as we go through. These tools are not always fast. We've got a whole lot of metrics here on the left-hand side that we can look into. This is a whole lot of pieces that have been recorded. So for instance, I can look here at the UI delays, and there wasn't much. If we just zoom into that, we can see that at this point here, my application, okay, was delayed for a period of half a second. So the UI thread was blocked. Or maybe I'm going to come down here and look at the window that was in focus currently. And so I can see up the top here that I had the performance recorder, I had Visual Studio, Windows Explorer, and then my application down the bottom here. And so this is showing the window that was currently in focus and useful for correlating numbers. So there's a large number of stats here on the side. And if we look down into some of the fun ones, we can load down into our XAML frame details, and we can go right down to a work breakdown. So this is this piece that I was trying to say. I'm just going to expand this, and this will take a little bit to go through, but just to show you this, the detail we get. So here what we've actually got is all the details about measuring, arranging everything the operating system and the framework is doing under the hood per element. So if you want to know what's taken a long time, you're able to go in here and see, okay, this panel, which had a hub section, so it did all this measure, apply template. This is the full details of everything that XAML is doing under the hood. So if you've got some issues, you're able to go in here and take a look. But trying to get numbers out of this is like anything with performance. You've got all these numbers, and trying to find anything is like pulling blood out of a stone. We're going to see how to do that in a minute. Let me just... Okay, flick. No, this one here. Okay, and going forwards is always a good thing. So just some screenshots of some things of what those screens would have looked like, at least on my slow device. If we've got an issue with application code, we see all these green bars in this tool. And I really recommend that this is the tool where you start off with. If we've got a parsing issue, we might see something like this, with all these blue bars and that big tree going on. That's a bit of a giveaway. Element overload. There's one where everything froze because there were way too many elements. And if we look at that element count, you can see I had 7,500 elements that I was trying to show at that time. So that one there's not very flash. So that's a little bit about some of the fast ones and a couple of the tools. Any questions about that stuff? Anything more you want to see before we jump onto the next bit?
That second tool that you showed.
Yes.
That, I don't need any.
No, so that second tool, the Windows Performance Toolkit, you can download directly. It's part of the Windows SDK. Okay, it's a separate download that you can grab and download. It is available inside Windows 8, but 8.1 gives us all those extra scenarios around XAML. Windows 8 only gives us a default recording profile of the CPU and some of the operating system metrics. Yep, go. Yes, I'll show you how to do that in a minute, about how we can customize those things and how we can actually pull some real data out of them, because that screen there was just overload. Okay, and I get completely lost. Anything else? So I just want to talk a little bit about Fluid. So that was fast, and then we took a sidetrack to show you some of those tools. What happens with Fluid? Now, I really wish I could have shown you these on this device, because the device would have used it up. It would have really shown them. But we'll see what we can do on my laptop. We've got two threads involved here. We've got our UI thread, as we mentioned before. This is the same as before. We've got our three, but I've skipped out the last one. Our UI thread creates our UI elements. And so it creates more elements as the user scrolls around if we're using virtualization, and runs all our application code. Well, the render thread, when we're scrolling, is moving all our visuals, so applying our transforms, playing our animations, and composing those elements. So when I'm talking about Fluid issues, we're talking about those black boxes you saw before. Well, let me just run this. Let me jump back to my laptop and run this application again. And I'm just going to show you some of those Fluid issues. Let me see if I knock my speed down on my operating system. It might show them up a bit better. This is why you want to be testing on these devices. So the first one, okay, is incremental. So as I scroll along, I'm seeing all these black boxes. So it wasn't able to keep up with me. Or maybe, even worse, under Windows 8, not under 8.1, by default this starts looking like, okay, it's just completely jamming, it's not doing anything. Okay? On the other device, on a touchscreen device, this would have just shown a white page, completely blank. So I've got this thing that's just completely locking up, I'm unable to do anything. So that's a Fluid issue. Something on the screen isn't able to keep up with me. Or maybe we've got this other issue here on the side, or I've got this screen, which has got a lot of overlays on it. If we look up in the top right-hand corner, there's a frame rate counter. And this frame rate is, you can turn on in code, it's one line of code, and by default it's on inside 8.1. It was available inside 8, but it's not actually on. And if we look at that, my machine's fast enough. Okay, we'll add more things to the screen. That frame rate would have dropped down quite significantly on our other machine. So just before I remember, let's hack up that demo a little bit more. And I'm going to add 10,000 elements to the screen. So we've got those two threads at play. We create the UI elements and we move things around. Not doing very well. So if we've got a Fluid issue, the screen's not keeping up, what's happening? Well, we might have too much layered transparency. So we might have too many elements trying to be drawn over on top of each other. That's when that last DWM can't keep up. We might have too many elements in our item templates, so that as it's trying to create the item templates, it's taking too long on the UI thread. We might have too many things already happening on the UI thread. So if the UI thread is needed, and we're going to talk about this as part of virtualization, but it's already doing something, it's unable to provide data up to the front end. And therefore, the front end's blocked, and it's just showing either those blank pages, or it jams and doesn't move at all. Or maybe we've got dependent animations. So I mentioned before that independent animations can be run completely on that render thread without an UI thread. Dependent animations, which is a thing you can turn on, call back to the UI thread every single frame. So if we think about what we've got in a frame, we've got 60 frames per second. A bit of math says that that's 16 milliseconds per frame that you've got. So you've only got 16 milliseconds to do all of your application code and for the operating system to lay that stuff out. So really you've only got about 8 or 9 milliseconds to do your work. So if anything on the UI thread is happening that takes more than 8 milliseconds, then you're going to be blocked. So I've mentioned before diagnosing fluid. We really use exactly the same tools that we saw before. And I'm not even going to show you them. Actually, let's take a look at some of these. Any questions while we're just getting this set up? Okay, so if we take a look while we're scrolling away, if I just leave that, I'm going to go back and run that UI responsiveness again on my machine. And I'm going to set my power back up to full because otherwise this will be really painful. So I'm going to run this. I need to get rid of that first piece. And if we go to the screen here, okay, which loads, so we've got issues there. There's definitely an issue there. And then let's go back to our overlays. We added a whole lot more. And we can see here that this is struggling to keep up this time. So stop the collection. And let's see what that looks like inside here. While we just wait another minute, talk amongst yourselves. But thankfully, I've already got some of these ready. So this one here shows an issue with GPU overload. This was my first scenario where I had all those overloads on top of each other. And you can see that that green line has jumped right down to only 30 frames per second. So that means that the GPU wasn't able to keep up because we can see there's nothing really happening in the rest of the system. So the rest of the system's fine. Here's an example with complex layouts where there was too much work happening and we can see that there's heaps and heaps of layout code that's just continuously happening and that's not able to keep up. And if we want to, we could dig down into those elements again to see exactly which elements are going wrong. Oh, I'm back to my screen. We can... Questions? Was that? No worries. Okay, we'll dig in a minute into the tools that we've got. I just want to show you this last one, which is another new tool that's inside Studio 2013. And this is about efficiency. So if we flick back again to my laptop, swipe back into there, I'm going to run my last tool here, which is called the energy consumption. I'm going to kick that one off. And this here is trying to measure, it'll give us an estimate of how much battery life your application's using up. So let's go over here. We've got our GPU, we're doing a whole bunch of stuff. And this application is not going to show it very well because it doesn't have lots of network, but that's okay. Let's just keep going around. Cool, close that down. Go back to Visual Studio and stop collection. So battery life we've said is important because users are trying to take our devices around, with them. Or if battery life gets slow, then they're going to uninstall it. Especially in corporate things, I've been doing some line of business applications, and if the guys who are out on the road can't keep their device on for the whole day, then the whole point of it's an absolute waste. So what this tool does is down the bottom, it said this session's consumed approximately 41 milliwatt hours of battery charge in X seconds. It's really useful for comparing things. So it's given us a number, and if we had network traffic, there would have been a lot of network traffic down under there. And under this, we've got an idea, okay, well the CPU's the one that's contributing. So it's given us a breakdown that it's estimated of how much battery life this is going to be using as we go through our application. And I've got my markers in here, so I can see that as I navigate around, okay, here's the piece that's taking all the time. Underneath it will also show all the 3G and the Wi-Fi that it was using, and it gives an estimate of how much power that would have used as well on our device, which is really useful. When we're dealing with these devices, the network's really interesting. So I don't know if you're aware, and I'm not a telecoms guy, but there's quite a big difference between using Wi-Fi and using 3G. So if we're using 3G, what happens on our devices is it connects up at a full power state, and then as time goes on, maybe after 30 seconds it drops down to half power, and after a minute or so, it drops to almost a sleep mode. So if we do things that are continually polling every 10 seconds, it's going to keep that alive at that full power mode and chew up our battery. Whereas if our application is maybe doing lots more work, but only every 5 minutes, we're going to be a lot more efficient on that 3G network. Whereas Wi-Fi is different, because Wi-Fi doesn't take much to connect. So this tool would have shown that stuff if we had much network going on. So there's an example of that. So I want to go into another demo to show you about how to instrument your code a little bit, and how to get some of this logging into your code and then back up into the tools. You'll notice here that I've actually got logs as part of, I know you won't notice there because I'm not on my laptop. You'll notice up here when I'm on my laptop that as part of these traces I've actually got markers to say I navigated to a hub page or I did some other work. These are all custom, and we've actually got some other really nice custom pieces that are now part of Visual Studio. So what I'm going to do is, let's just take a look at this from a code perspective. We've got 2 new classes. No, let's not do that one. Let's do, when I first get to the hub, I'm just going to make, we'll do it inside the load data method. Let's make some calls to be able to log some data. So inside Visual Studio now, or inside Windows 8.1, this is a new API that's part of Windows 8.1. It's called a logging channel. And so I can create a new logging channel, and I'll give it a name, TechEd. And underneath that logging channel, it's really easy. I can call log message. Done. That's all I need to do to get messages to show up into there. And even better, this comes into the full underlying subsystem here of Windows. Let's just ignore those pop-ups. Now the other piece I can do, if I want to time something. So let's say I want to time this work that I'm doing underneath. So I can now go create an activity, if I could spell. And I'm going to give that a name. So loading hub. And I'll pass in the logging channel. Once again, how about I actually finish typing that in? Cool. So I've created an activity, and this is going to give me a start and a stop. Cool. Waiting for these diagnostic things to save so I can actually run the application. And there's no cancel button on there. This is something that's not very fast and fluid. So I just want to run that performance diagnostics one last time so that you can see that those markers have hopefully come in there. So run up the app, boot it, and should have happened already. So go to the hub page, we'll close that, and stop collection. So hopefully when it analyses this, we should see some markers in here, and we didn't. So that's interesting. Okay, I think it only picks up things off the UI thread. Anyway, we've got other ways of getting this. So let's move right along. And we can load up perfmon. Did I even put that inside the right method? That's probably a good place. Let's loading our state. Yep, that should be where it goes. Okay, let's load up perfmon. Because this is built on top of the underlying system of event tracing for Windows, I can now, under a user-defined dataset. Cool, so let's create a new dataset here inside perfmon. So I'm going to create a new data collector set. We can see that. Okay, and I'm going to call this TechEd. This is not really the easiest. And I'm going to add a trace. These pieces here will come under a trace, and this one here took me absolutely so long to find and figure out. There's zero documentation around about this. And there's a trace called Microsoft-diagnostics-logging channel. So while we wait for this to load up, I should be able to select this logging channel. And because it's part of perfmon, I can now get that saved and see it inside Event Viewer. I can get that to go out inside a device. And I can control this from outside of my application, which is really nice. There's also ways to be able to do this inside the application. So if we go Microsoft.windows.diagnostics.logging channel. So I'm going to add a listener to that, and that's the listener for any logging that we do inside our application. So I've set that one there up, and it doesn't even want to run it. I can enable this, and it's set up at the moment. It's going to log it to a file, and the file is going to be called something like this. Under my users, app data local TechEd. So now that it's playing, I can run my application again. And hopefully our logs will go into there. Let me just... So that's cool. We'll see that in a second. And what I actually want to do is go back now to Performance Recorder. We can also include these logs inside the Performance Recorder by adding a specific custom channel. This is up on my GitHub repository, so if you want to add this into your system, we can add this custom recorder. I can click Start here. We'll run our application again. And close it down once she's actually finished loading, which it has done. So we'll close that down. Stop. Save my recording. Save it there. It's much faster because it's not doing anything. And open it up again inside Windows Performance Analyzer. Now these events show up under this generic events one. And hopefully, if I expand this guy here, and this is really, really hard to read, I have got a number of events. Logging channel. Okay. And here we can see I've got some events going on. These are all my custom events, but they're really, really hard to read. So what I'm going to do is apply a transform, which is hopefully on my machine, and it's not. So that's interesting. That's not the one that I wanted to do. Let's just move this around so we can actually see how this works. I'm going to move in here to the event view, and I'm going to take the time and move the time there. And we've got all of our custom events here inside the application, which we can correlate back with any of the other existing events. If I just go back to this one here, which was my previous capture that I'd done. Again, this code here is really hard to follow. So what you want to do is click Profiles and apply a profile. There's some that are built in, and the easiest one I'm going to do is XAML application analysis. And what that's done is that's pulled out the metrics that are actually really interesting to give us the big picture. So the window in focus, what's happening on the DWM frame, what's happening on my disk usage. Under the frame analysis, what's happening at all these points. And we should be able to see that on this last one, we've got my application logging events down the bottom here, which when they load are linked in by TechEd channel. And if we just expand this guy here so we can see it, here's all my custom event logging pieces. So I'm able to correlate those back with all the other data that's coming inside the system. Any questions on that just before we move on and I go through actually all the ways to fix this stuff? We don't have much time, so let me go through some demos on this stuff. Okay, so that's a little bit about that. Logging channels. How do we fix this? Well, the easiest is to go through the cycle of identifying, measuring our issues, analysing them back in the other tool, and then modifying them. The first fix I'd call up was the design. So your design, your UI design potentially needs to change. If you've got too many elements on the screen, maybe you need to change your UI design. The second one is to retarget it for Windows 8.1. There's a huge performance difference between 8.1 and 8 that's built into the operating system. They've done things like pre-compiling all your XAML, fixing up all the C# references, and optimizing all of the templates. Here if we go, here's a video comparing 8.1 on the left, 8.1 on the right. Let's just replay that one again. So you can see that on the left is a lot faster. If we do that in slowed down speed, same one. This is a demo that yes. So on the left-hand side, Windows 8.1, same application, faster to load up a grid view, 0 changes apart from retargeting. So if you can, retarget for 8.1. Same with panning. The right-hand side, Windows 8.1. Left-hand side, Windows 8. Windows 8, you've then lost, looks like the user's, nothing's happening. That was that blocking we saw before. 8.1, at least is using placeholders, and is much, much faster. So you want to be able to minimize the work you're doing. Yep, was that a question? No, sorry. Minimize the amount of work you're doing, simplifying your templates. And if you're using images, make sure you use thumbnail images, because using your massive images inside your grid view is really, really slow. I just want to talk a little bit about virtualization. So virtualization is really, really important inside of our applications with our big grid views. Virtualization means that, say we've got a screen like this that's got our screen in the middle that I've outlined in black and all of the elements. We don't want to have to load all those up front, especially if it's massive. If we're loading, you saw before, 7,000 elements on that piece, that's going to take forever. So what virtualization does, built into the operating system, is it only loads the little pieces on the side. So that as I'm scrolling through, it recreates the next lot of templates. Now this makes a difference because, as we saw before, the first one can be done completely inside a transform on that render thread. So there's no application code involved. Whereas this time here, every time it tries to recreate another template, it's having to pull in some application code. But it's able to run much faster, and moving that transform is much quicker because it's a much smaller amount that it's dealing with. So virtualization is on by default in all the list views and the grid views. And it's actually quite hard to not turn it on those. But you'll see it if you've got something like you've got a big grid that you're creating yourself with elements inside it. You need to work towards using virtualizing stack panels and similar things. Anyone had issues with virtualization in the past? Getting that going? Any questions about it? Or? No, just had issues. Okay. So virtualization is important, but thinking back to how those things work, if we're using virtualization, we have to be worried about our app thread. If we're not using virtualization, it doesn't actually matter. Placeholders. Placeholders are there by default inside Windows 8.1. When you saw back on the other screen, if we going back inside our application, when I had placeholders on, you'd see those black boxes as we were scrolling through. So if I go here to something that's using this one here, I've got placeholders on at the moment. So as I scroll through, if it can't keep up, it shows a black box. That shows to the user that something's happening. If I turn off placeholders, so we'll do that, and then I'll redo that same scrolling. On this device, because it's a desktop device and I'm not using touch, it just locks, it just runs slow. On a touch device, it would actually show a completely white screen. So the placeholders are there as a part of quick thing to let the user know that something is happening, something is coming. They're on by default on our grid views and list views, so that's really, really nice. And to set them up, all you need to do is set the show scrolling placeholders to be true. Now, I've only got a couple of minutes, so I want to show you these ninja stuff, multi-stage data templates. As part of 8.1, let's say we've got these slow templates that are running. We're able to set up a multi-stage data template which says only load part of the template, or here's the order I want you to do to load part of the template. So if we jump back inside our application, I want to... Yep, no, I'm just fixing up something before I change the screen so that you don't see that I've just optimized this for my PC instead of the other one. What I've got here inside... Okay, inside this class is a property that runs slow. This is just to demonstrate this. So here's a property, and I've put a tight loop inside there from I to 60,000. We'll see if that number's about right on this machine here. So when I run, now don't do this inside your application. If you're trying to performance tune and you find one of those, get rid of it. It's probably the cause of your issue. So I want to load up this one here. And you can see that the templates there are taking, quite a while to load. So we don't want that. We want them to be fast. If I go back to that screen, and inside the XAML, if I change my template to get rid of that slow property, so I'm just going to comment that out. So I just want to show you the difference that this makes. This is data binding, showing that data binding can actually have an issue on your application if the data binding is slow. So let's just run that same screen, and now I'm going to scroll across. Okay, and it's still not perfect, but it's significantly faster. So what I can do is I'm going to turn on this piece called multi-stage rendering. And I've already turned it on inside my grid view. I'm using a library that I actually created, but this is part of the operating system. And I'm going to say I want it to use phases. And I'm up here on the slow property. I want to say that I want this here to be in phase 2. So renderlib render.phase equals 2. Let's try running this. So I've still got the property on the screen, but I'm telling it that I want it to render the rest of the template before it renders this property. So if we just go through that, it's still responsive, and then that property pops in later. So what this means is that we've not sacrificed any speed for complexity. Now you could do this especially with images, so we could get this even better. And we could say that the first one that we want to do is maybe a background. Or let's make our image happen at the end. So renderlib render.phase equals, I'm going to make that one 2, slow property 5, and let's say that at the beginning I want to put a background in there. Right, I'm going to make this one here too. And I'm going to put another border around the outside with a background equals red, so hopefully you can see it. So hopefully this means it'll show up red at the beginning. It's then going to load our image with its border, and then it will load the rest of the content. And I've put 2 things inside the content, so let me throw this border here right around the outside. Border, and close this guy down. Let's run the same piece. And you can see I've got red. Okay, that wasn't actually a very good demo because I never actually set the rest of the colour. But that's okay. So the idea with this, though, is that we've got fast loading, and then we can control ourselves how much we need to load. You only want to do this when you have to. But if you have to, it's a really, really powerful tool. So just to wrap up, here's the code for this if we're doing it inside code behind. You can see we've got phases. And I can say, show this one first, show the second one. But personally, I much prefer this implementation because it's there as part of the data template and it's able to be seen. So that's pretty much what I was wanting to show you today. Those are some of the tools that you've got available that are new inside Studio 2013. When you're trying to make your applications fly, you want to find the cause of the issues. So 2 of those tools are the Performance Hub and the Performance Toolkit that are now available. You want to retarget it for 8.1 because 8.1 is just a whole lot faster. You want to simplify your screens and make use of some of the additional performance things. Questions as we wrap up? Any gnarly performance problems you want to throw at me live on stage and see if we can sort them?
Does all that profiling work in C++ and JavaScript as well?
Yes, so there is a JavaScript UI responsiveness tool as well. And there's actually, if you've seen the IE11 responsiveness tool, something very similar to that breakdown is now part of IE11. If you just hit F12 under the developer toolbars, that actually breaks it down with layout and all the other pieces. But yes, those similar tools are available for C++ because that performance recorder is just Windows numbers. It's event tracing for Windows, all of that stuff, and there's heaps of detail that I didn't actually show you. But that's all in there.
So those tools also Windows Phone?
No. The UI responsiveness, I believe, works on Windows Phone, but I've only had this for 2 days and I haven't tried it out, so I can't. Yeah, it'd be really nice if it could. The same techniques would apply, though. Anything else, guys? Yeah, okay.
Did you say the regular stuff was a third-party thing? Or is it
That's my code. It's on GitHub. If you go to GitHub and did I include it? I was going to include a link. Looks like I didn't. If you go to GitHub/KiwiDev, it's under there. Okay. Otherwise, the code behind it approach is available. There are a whole bunch of build videos that are on performance, and the MSDN Performance Hub is actually starting to get some decent things. So my Twitter handle is KiwiDev. Feel free to fire any performance questions my way, and I'll send you to the right place, which is not necessarily me. Anything else? I think we'll wrap up. Please fill out your evals. And I'm speaking this afternoon on C# async, which is actually going to be a really fun talk. So come along to that. You're going to get to see me coding live on stage, throw rotten tomatoes, all sorts of things. Hopefully make Ivan's brain go, but I don't think that's going to happen. Yeah, good luck with that one, I'm told. That's me if there's nothing else. Thank you guys. Thanks for coming.